Hi, my name is Orett Whyte, and my team members are Gabriel, Saintvil, and Mohammed, Alharim, and we'll be talking about a gearbox design. Gears are one of the oldest pieces of equipment known to mankind. Gears can be traced back to the Chinese sword pointing chariot of the 27th century BC. Spur gears are some of the most commonly used gears in mechanical designs. They are frequently used for larger gear reductions. Spur gears are used in many daily mechanical designs such as lawnmowers, washing machines, watches, and the automobile industry. My team and I were tasked to design a gearbox capable of transmitting 3 horsepower while reducing speed from 360 RPM to 20 RPM, with both gears and shafts being on a parallel plane, with input and output being reversed.
Alright, this is the analysis portion of the project. We chose a compound reverted gear system and a velocity ratio of 1/3 times 1/6, which equals 1/18. With a velocity ratio of 0.055. The system has a 2-step down. From our calculations, the E equal output over input is 1/3 times 1/6 equal 1/18. The pressure angle of the gear is 20 degrees. The bore diameter of the gears is 0.125, 0.1875, and 0.250 inches. The number of teeth for the gears are 48, 16, and 96. These are the different alternative designs we came up with. System 1 has a velocity ratio of 1/2 times 1/2 times 1/3, which is 0.833, which is way off from the choices we have. System 2 has a velocity ratio of 1/4 times 1/2 times 1/2, which came close to the velocity ratio we needed, but it was 0.625, and System 3 had a velocity ratio of 1/2 times 1/3 times 1/3, which is the target velocity ratio, but we could not use it because it's a 3-step and we needed a 2-step. These are the dimensions we have. These are the choices for the gears, the shaft, and the bearings from each catalog. Alright, this is the gearbox setup of the animation. This is the gearbox. This is what's going on inside the gearbox. And inside you can see the input shaft, which is there, and on the other side you see the output shaft.
Pictured in this slide, we have a Boston Gear catalog for spur gears, including the page from which our gear selections came from. We assumed the pressure angle of 20 and used a diametral pitch of 6, and the chosen materials were steel and cast iron. Using previously obtained information such as the bore diameter from the Boston Gear catalog, we were able to then select our bearings from the Timken catalog pictured behind me. The specific series is an extra small 33 inch series. In order to perform the gear analysis, we needed to follow the AGMA procedures pictured behind me. This includes a very detailed listing of what tables to use to obtain the pertinent information to the problem. The next slide also depicts the same procedures used for the contact or stress analysis. After conducting all these studies upon our gearbox design to see if it satisfied the conditions, it's very important to note that maintenance must be taken into account. If it's not kept lubricated and vibrations grow too strong, these numbers will then vary and our design and studies may not be valid anymore. In conclusion, given our constraints and parameters, our design was successful as it did not fail any of the AGMA procedures. It was also relatively on par with the market cost, with an approximate cost of around $900. But this could be driven down if it was heavily manufactured as opposed to a one-part customized job.